all, my name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about the hit or miss transformation. The hit or miss transformation is a general binary morphological operation that can be used to look for particular patterns of foreground and background pixels in an image. It is actually the basic operation of binary morphological, since almost all the other binary morphological operators can be derived from it. With the other binary morphological operators, it takes as input a binary image and a structuring element and produces another binary image as output. Suppose if I am taking one image, this image I am taking as a 3x3 matrix. So suppose it is one image or one object. So it is the background, it is the foreground. So if I am taking the background, suppose my intention is background I need a black, foreground I need a white. So what I have to do, whenever the background is there, I am taking 1 or 0. Foreground I am taking as a 0, 0, 0. Otherwise, I will take as a backgrounds are 0. What is the image is there? I am taking as a, it is 1, 1, 1. So here the binary. So foreground is a, these are binary or not? Yes, these are the binary values. So if I am taking the binary values with respect to the foreground and background. So background, maybe the objects are there or may not. In the foreground, maybe objects are there or may not. Here I am taking one example of some object is there. I am taking as a foreground and background I am taking. Otherwise, suppose foreground I needed to do a blur or I want to highlight the background. So what I have to do? Background I have to highlight. So you have to take one foreground. I no need of highlight of that one. So I have to go for the blurring. So background is 1 and foreground is 0. So what it may be, what your requirement, you have to take the binary values only. So binary values I need to change the anything. So the hit or miss transform is a general binary morphological operation that can be used to look for particular patterns of foreground and background pixels in an image. But it is actually the basic operation of binary morphology, since almost all the binary morphology operators can be derived from it. So here operators means, what are the operators we are taking? Suppose I am taking erosion, dilation, closing, opening, hit or miss. So these are the 5 types of morphological operators. So which operator you are doing? Suppose for example I have to go for the hit or miss transform. No, I need a erosion, I need a dilation, closing, opening, or hit or miss. So these are the operators. But the binary morphological operators, binary means I am taking in the form of 1 or 0, and input binary image and a structural element, SC structural element, and produces another binary image as output. So morphological image or structuring element I am taking as a binary, and output after the modifications or after my requirement, binary output is also in the form of binary only. So the structuring element SE used in the hit and miss is a slight extension to the type that has been introduced for erosion and dilation. In that it can contain both foreground and background pixels rather than just foreground pixels, that is both ones and zeros. So the simpler type of structuring element SC used with erosion and dilation is often depicted containing both ones and zeros as well. So but in the case the zeros, really stand for don't cares and are just used to fill the structuring element to a convenient shaped kernel used a square. So whatever may be, if I'm taking the foreground or background, one, suppose I want to highlight the background, so it is called a don't care. So foreground condition is don't care. Suppose background I want to not highlight. Foreground only I want to highlight. So here you have to take the don't care condition. So which one you have to highlight, you can highlight. Remaining all you have to go for the don't care condition. Here also the structure element used for the hit or miss in a slight extension to the type that has been introduced for erosion and dilation. But in that it contains both the foreground and background pixels rather than just foreground pixels, that is both ones and zeros. But the simpler type of structuring element used with erosion and dilation is often depicted containing both ones and zeros as well. But in the case of zeros, really stand for don't care. When I'm going for the zeros, my condition is don't care. When I'm going for the one, you have to highlight. You have to highlight the image. So do you want to highlight the image? You can take one. Otherwise, you have to don't care. Then you have to go for the zero. But the binary operations are important. Binary means in the form of ones and zero. But used to fill out the structuring element to a convenient shaped kernel, usually a square. But in all our illustrations, these don't cares are shown as blank in the kernel in order to avoid confusion. So when I'm going for the don't care, you have to blank that one. Okay. Suppose one, I have to go for the white. So white means what I got zero, it is a black. So if I am taking the one equal to white, definitely zero is a black. So my equation is 1 equal to white. Otherwise, 0 is obviously a black. Empty is nothing but a don't care. I don't want anything on that place. So I don't need of any background or any foreground for particular images. Okay, you can go for the don't care condition. Here, one example of extended kind of structuring element in the shown below is usually we donate foreground pixels using ones and the background pixel is using 0. So when I'm going for the ones, these are all foreground. When I'm going for the zeros, these are all taking as a background. Okay, so this foreground and background pixels are using here extending the type of structuring element used in hit or miss transformation. So what is a hit or what is a miss transformation? So suppose here I'm taking 1 is a white, 0 is a black. But what about here 1 is a, I'm taking as a here foreground. And 0 is a background. So when I am taking the 1 equal to foreground and 0 is a background, so this one I am taking as a foreground, these zeros as a background. So here what about the background? Here zeros. So I am taking a background equal to black and foreground is equal to white. So for foreground I am highlighting with ones, background is I am not highlighting with zeros. Okay. So what are the empty cells are there? I am taking as a don't care. So that is here defining that don't cares are shown as a blank in the kernel in order to avoid confusions. But an example of extended kind of structuring element is shown in below. As usual, we note that foreground pixels using ones and background pixels are zeros. Okay. So foreground equal to 1, background equal to 0. Foreground equal to 1, background equal to 0. So 1 equal to white, 0 equal to black, like this. So it is one example of extended type of structuring element used in hit or miss operations. The hit or miss transformation of an image A by B is denoted by A into B. So I am taking as an image with A into B. So B is a pair of structuring elements. So already we know that B is a structuring element. So B is a structuring element and A is the operator. So which operator you are using? That is the image of the transformation function A. So here B equal to B1 comma B2 rather than a single element. You have to take, I am taking here structuring element as a B equal to B1 comma B2. So B1 equal to set of elements of B associated with an object. B2 equal to set of elements of B associated with the background. So object is equal to B1 and background equal to B2. So what about object means? Definitely it is a foreground. Foreground. If I am taking foreground equal to 1, then obviously background will be 0. Okay, 1 equal to I am taking as a white, 0 is obviously a black. So the hit or miss transformation defined as A into B equal to A to B1 of transformation with A complement of B2. So the transformation is useful in locating all pixel configurations that match the B1 structure, that is hit, but do not match the B2, that is a miss. Thus the hit or miss transform is used for shape detection. So definitely here it is the foreground about background, and we are taking as a two transformation functions, that is A and B. A is the transformation function or operator and B is the structure element. Here I am taking the two structure elements B1 and B2. Here B1 is called the object and B2 is called the foreground. So when I am taking the B1 equal to object, I am taking as a foreground and B2 is a background. So I am calling it is a 0. Suppose I am taking an object as a foreground, that is white, definitely background is black. So it is the locating of pixel in configuration of B1 structure. B1 means foreground, sorry, object, and hit. So B1 equal to hit or is equal to miss, hit or miss transform. So I am calling as B1 equal to hit here. Miss the transformation used for shape detection. Here the figure is the binary image and it is a hit or miss transform. So what is the difference? Here how many objects are there? Here 4 objects are there. So here objects are taking as a foreground. So this background equal to 0, this foreground equal to 1. So I want to remove all these things. Only I want to highlight this element. Okay, remaining all background equal to 0. It is only foreground. So if I am taking the foreground and background, just I was changed, instead of white cells I am taking as a 0. Suppose this matrix I am taking as a 3 by 3 matrix. So this 4 by 4 matrix, if I am taking background equal to 0, foreground equal to 1. So what are the backgrounds are there, that I am taking 0. And background equal to 0, that is, and foreground equal to 1. So when I am going for the background and foreground, this one background is all zeros, foreground equal to ones, but I don't want to highlight these ones, so I want to convert this foreground to the background. foreground is changed to the background. So 0, 0, 0, 0, 0, 0, 0, 0. So only these ones are there. So only these ones are foreground, remaining all background. So from this matrix to this matrix, what is happened means foreground I am changed to the background. So foreground only four cells are there, 4 pixels, 1 1 1 1. But is it changed to 1 1? Remaining all background means that is 0. So here also, what are the backgrounds are there? That is I want to change to 0. Only foreground that is changed to 1. That is called hit or mistransform. So the hit and miss operation is performed in much the same way as other morphological operators by translating the origin of the structuring element to all points in the image, then comparing the structuring element with the underlying image pixels. If the foreground and background pixels in the structuring element exactly match foreground and background pixels in the image, then the pixels underneath of the origin of structure element is set to the foreground color. If it does not match, then the pixel is set to the background color. So here I am taking only two concepts, background and foreground. So the hit and miss operation is performed in much the same way as the morphological operator by translating the origin of the structuring element to all points in the image, then comparing the structuring element with the underlying image pixels. If I go in the foreground and background pixels, these are there in the structuring element. So these are belongs to structuring element. Exactly match foreground and background pixels in the image. If the pixel underneath the origin of the structuring element is set to the foreground color, so when it is pixel underneath of origin of the structuring element, that is the foreground color. If it does not reach, then it is background. If it is reaching, I am calling as a foreground equal to 1. If it is not reaching, background equal to 0. That is a concept of hit or mistransform. For instance, the structuring element shown in the below figure can be used to find the right angle convex corner points in an image. Notice that the pixels in the element form the shape of the bottom left convex corner. We assume that the origin of the element is at the center of the 3 by 3 element. In order to find the corners in a binary image, we need to run the hit or mistransform 4 times with the 4 different elements representing the 4 kinds of right angle corners found in binary images. So the below figure shows the 4 different elements used in this operation. So here finally I am taking 4 elements are there. These 4 elements I am taking as objects, but the structuring element is the to finding the right convex of the corner means foreground or background. So the pixels in the element to form the shape of a bottom left convex corner, we assume that the origin of the element is at the center of the 3 by 3 element. But in order to find all the corners in a binary image, we need to run to hit or mistransform 4 times with the 4 different elements representing the 4 kinds of right angle corners found in binary images and 4 different elements used in this operation. It is one example of 4 structuring element used for corner finding of binary images using the hit miss transform. Here I am taking 4 structuring element. 4 SC elements are there for corner finding to binary images using hit or miss. So here first matrix, how many ones are there? Here 3 ones and 3 zeros are there. So these 3 ones are shifted to here. So these 3 are this corner, it is shifted to this corner. Actually these are in this side, but I have shifted to this side. Here these three are shifted to here. Finally it is shifted to here. So we are ones and zeros are changed. When we are changing the zeros and ones, definitely the background highlighting will be changed. So it is background is also changing. So zeros are there. Here zeros means it is a background. Which position is there? Background is the left corner, but its background is changed to the right corner. Here it is the top left, top right. So like this. So I have changed the background with respect to the structuring element used to corner finding out the binary images for the hit or miss transform. Using the hit or miss transform, I changed the foreground. Here foreground is like this. Here it is changed to like this. Here like this. Here like this. Okay. So the foreground and backgrounds are changed with respect to the hit or miss transform with binary images. After obtaining the locations of corners in each orientation, we can then simply all these images together to get the final result showing the locations of all right angle convex corners in any orientation. So the below figure shows the effect of this corner detecting on a simple binary images. So here figure A and figure B is there. So the effect of hit or miss based on right angle convex corner detector on a simple binary image. So from input to output, what is happening means hit or miss transform is based on right angle convex corner detector on a simple binary images. So what are the highlighting? Suppose here ones are there. How many ones are there? 5 ones are there. So it is only one is there. Remaining what happened? Remaining are converted to these are converted to the zeros. So here also these are all zeros. So zeros are nothing but it is converted to the background, that is black. Here only foreground. Once. So after obtaining the locations of corner in each orientation, we can then simply all the images together to get the final result showing the locations of all right angle convex corners in any orientation. But here how we are changing the background to the foreground and the foreground to the background. That is the hit or miss transform of right angle convex. The implementations vary as to how they handle the hit or miss transform at the edges of images where the structuring element overlaps the edge of the images. A simple solution is to simplify, assuming that any structuring element that overlaps the image does not match underlying pixels, and hence the corresponding pixels in the output should be set to 0. So the hit or miss transform has many applications in more complex morphological operations. It is being used to construct the thinking and the thickness of the operators. So the implementing how they handle the hit or miss transform at edges of image where the structuring element overlaps the edges of timing. So a simple solution is to simplify, assume that all the structuring element that overlaps the image does not match underlying pixels, and hence the corresponding pixels in the output should be set to 0. And the hit or miss transform has many applications of complex morphological operations. It is being to construct the thinning and thickening of the operators. Okay, two operators here using. The hit and miss transform is used to look for occurrences of particular binary patterns in fixed orientations. It can be used to look for several patterns or alternatively for the same pattern in several orientations simply by running successive transformation using different structuring elements and then ORing the result together. So the erosion dilation, opening and closing, thinning and thickness. Okay, these are all the morphological. So erosion, dilation, opening and closing, thinning, thickening can be the derived from hit or mistransform in conjunction with simple set operations. So the below figure is a structuring element that can be used for locating various binary features. So when I am going for the hit or miss, it is used to look for occurrence of particular binary patterns in fixed operations. It can be used to look for several patterns, alternatively for same pattern in several orientations. But simply by running successive transformations using different structuring elements, when I'm going for the structuring element, the ORing the result together to the operation. So erosion, dilation, closing and opening are the major role of image morphology, and thinning and thickening can be the derived from the hit or miss transform in conjunction with simple set of operations. So the below figure some structuring elements that can be used for locating various binary features. So some applications of the hit and miss transform. So it I am taking as a figure 1, 2, 3, 4, 5. So one is used for the figure 1 is used to locate isolated points in a binary image. So definitely these are the binary, why? Because these are the ones and zeros, but it is locating as a isolated points. And 2 is used to locate the end points on a binary skeleton. Note that this structuring element must be used in all its rotations. So 4 hit miss passes are required. So here what are the zeros are there? These are I'm taking as a background. So one is a foreground. So these are empty because it is used to locate the end points. So we have to highlight the end. What are the end points are there on a binary skeleton? This is structuring element used to be in all restorations of 4 hit or miss passes are required. So 3A, 3B, 3C means figure 3, 4, 5 are the kernels used to locate the triple points, that is the junctions on a skeleton. So here all are okay. Here once it is shifted to there, here once like this. Okay. So some applications of the hit and miss transform. One is used to locate isolated points of the binary, and 2 is used for locate the end points of the binary skeleton, and according with the structuring element, and hit or passes are required. But here figure 3, 4, 5, that is a 3A, 3B, 3C are kernels used to locate the triple point junctions on the skeleton. So this is basically used for shape detection or finding particular patterns in a given image. The shape or pattern to match has to be provided via the structuring element. This transformation can be easily implemented using the erosion operation. Here we use two structuring elements, say B1 and B2. Already we discussed in this. We ask a simple question to B1 fits the object, B2 misses the object. If I am taking B1 is object, obviously B2 is not an object. So the pixels whose neighborhood exactly matches B1 while not being B2. If it is matches B1 means definitely it is not matching. It is not matching B2. So here B1 and B2 we are considering. So this B1 I am taking as a object, that is the white. It is not an object means it is a black. If it is white, I am taking as a binary is 1. If it is black means I'm taking as a black, binary is a 0. So it is basically used to shape detection, to finding particular patterns in the given image. The shape pattern match has to be provided via the structuring element. This transformation can be easily implemented using the erosion operation. So the two structuring elements, say B1 and B2, B1 fits, then it is called object. B2 misses, it is not an object. And the pixels whose neighborhood exactly matches B1 while not matching the B2 at the same time. The hit or miss operation can be expressed in terms of erosion as A to B. So when I am taking the equation for the hit or miss transformation, we are going for the foreground and background. So we are changing simply foreground and background. So foreground 1 and 0. Simply we are changing 0 to 1 and 1 to 0 like this. So we are assuming structural element SE and B1 and B2 don't intersect, otherwise this operation cannot be performed, because both B1 and B2 are disjoint sets. We can express both in terms of a single structuring element. Doing so makes the operation more interpretability, and see that T-shaped pattern in the image defined as a structure element of B1 such that it does not contain the pattern defined by B2 in its right neighboring, and 0 is represents the don't care about these operations. Okay, so already we know that don't care means you are not taking any 1 or any 0, but here structure element B1 and B2 are the don't intersect, otherwise this operation can be performed. But B1 and B2 are disjoint functions. Okay, why? Because these are inversely proportional. If B1 equal to foreground means B2 is obviously background. B1 equal to object means B2 is not an object. B1 equal to 1 means B2 equal to 0, like this. So this pattern of image is defined by a SE B1 such that it does not contain the pattern defined by B2 in the rightmost neighborhood. So it is one example of, I am taking A, B and C. Here A 1 1 1 and T I am taking as a T type. So here I am taking ones are converted to these ones. Whatever the ones are there, these are converted to the zeros. Already zeros are there now. These zeros are there, but here I am taking minus 1 minus 1. So 1 is converting to the 0, 0 is converted to the minus 1. So that is B1 into B2. So what is happening? Suppose I am taking B1 equal to 1 1 1 1 1 1 0 1 0 0 1 0. Okay, and B2 equal to 0 0 0 0 0 minus 1 0 0 minus 1. So what is happening means, with respect to the 1 into 0, we are highlighting the 1. What are the ones are there? It should be highlighted. What are the zeros are there? It should be highlighted. Zeros, in place of zeros, it taking as a minus 1. Okay, so it is a combining. So that is hit or miss transform. So that is a hit or miss transform. So B1 is a different matrix, B2 is different. We are combining with B1 and B2. So just comparing the underlying pixel values with the combined structure element, the matches exactly, then the pixel under path origin of SC is set to 1, else it is 0. Okay, when I going for the structuring element, if it is 1, set to 0, 1, otherwise it is 0. So we want to find the above combined structuring element in the image shown. Clearly, one the other lower right matches the pattern defined by the combining of structure element. The result is shown on the right side. Okay, we have to show the result. But here I am taking the structure element in the form of ones and zeros. What about 1 and what about 0 is there. So if I'm taking the 1 is a foreground, 0 is a background, foreground equal to 1, background equal to 0. So I'm taking this one original image, that is an input image, it is an output image, hit or mistransform. So what are the here 1. So it is converted to the 1. So here only this one is copied. What about remaining all means? Remaining all converted to 0. So like this are foreground, these are background. So then when this foreground equal to black, that means it is converted to the background. So how many foregrounds are there means only 1 pixel. So ones are changed to 0, 1 changed to 0 or zeros are changed to 1. That is a hit or mistransformation. So these are the references. So today we discussed hit or mistransform. We discuss again very briefly. So the hit or mistransform is a general binary morphological operation and it can be used to look particular patterns of foreground and background pixels. Only about the foreground and background. So the actual basic operation of binary morphology, the almost other binary operators can be derived, but in the other binary morphological operators takes an input binary image and a structuring element and produces another binary image as output. So the structural element used in the hit or mistransform is a slight extension of type that has been introduced for erosion and dilation. In that it can contain both foreground and background pixels rather than just foreground pixels, that is both ones and zeros. Similarly, the type of structuring element used with erosion and dilation is often depicted containing both ones and zeros as well. So in the case zeros really stands for don't cares and are just used for fill of the structuring element to convenient shaped kernels or squaring. So all our illustrations don't cares are shown as a blank. When the blanks are there, that is called don't care. When ones are there, I'm taking as a foreground. So when zeros are there, it is a background. So this extended kind of structuring element is shown in the below, and it is an example of extended type of structuring element with the hit or mistransform. And what are the hit or mistransform is the A and B. Here B1 and B2 are the structuring elements. Here B1 equal to elements of object and B2 is the background. Object is nothing but a foreground. It is about the foreground and background. It is a binary image result of applying the hit or mistransform. Means the binary background is converted to the black. So background is 1 means what are the foreground values are there converted to the background. So the hit or miss operation is performed in much same way as a morphological operators by translating the origin of the structuring element. But the structuring element exactly they match the foreground background pixels in the image, but underneath the origin of the structuring element SE. And it is a don't care or doesn't match with the pixel is set to the background. Okay. So if it is set, it is 1. If it is not set, it is 0. The instance of structuring element in the shown below. To find the right angle convex corner points in an image, the pixels in the element form the shape of a bottom left convex corner. We assume that the origin of the elements are 3 by 3. And to find all the corners in the binary image, we need to run the hit or miss transform 4 times with 4 different elements representing the 4 kinds of right angle corners found in binary images. Okay, it is one example of 4 structuring element used for corner finding in binary images using the hit or miss transform. So the background and foreground values are changed. Zeros and 1 values are changed. The positions are changed. Means the foreground and background values also be changed. After obtaining the locations of corner in each orientation, we can then simply OR the images. Means OR means in place of 0 to 1 or 1 to 0. And it is we are implementing the handle the hit or miss transform of the edges of image where the structuring element overlaps the edges of the image. But the structuring element that overlaps the image does not match underlying pixels, and hence the corresponding pixels of the output should be a 0. But here hit or miss transform has many applications in more complex morphological operations, and it is being used to construct thinning and thickening operators. Only 2 operators, thinning and thickening. So the hit or miss transform is used to look for occurrence of particular binary pattern in fixed orientations. It can be used to look for several patterns or alternatively for the same pattern in several orientations as above. But the erosion, dilation, opening, closing, thinning and thickening are the morphological operators deriving from hit or miss transformation conjunction with a simple set of operations. So it is one example for structuring element that can be used for locating various binary features. Okay, some applications of the hit or miss transform. Figure 1 is used for locating the isolated points in binary. 2 is used for locating the end points of a binary skeleton. Note that the structuring element must be used in all rotations of hit or miss passes the required. 3A, 3B, 3C. That means figure 3B, figure 3, figure 4, figure 5 are used for locating the triple points, junctions on a skeleton. So only these are changed. So that is the reason we are taking as a star value. So the basically used for shape and detection of finding the particular pattern in the given image. The shape pattern to match has to be provided via structuring element SE. So the structuring elements by B1 and B2, we ask a simple question to finding out B1 fits the object while B2 misses the object, and the pixels whose neighborhood exactly matches B1 while not matching the B2. And the hit or miss transformation equation is following. Here B1 and B2 are the intersections of image transformation of hit or miss. Here one example of two matrix B1 and B2 multiplying with or combining with another matrix, that is a combined matrix. Here I am taking the ones and zeros of a structure element. Here it is hit or miss transform. It is an input image converting to the hit or miss. Means how many whites are converted to black. So foreground is converted to the background and background is changed to the foreground. Or only here the foreground is changed to the background. What are the foreground pixels are there? Here only one is there. Remaining all changed to the background. That is converted to black. So white is converted. Most of the whites are converted to the black. Only one pixel. So it is nothing but a hit or miss transform. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.